All right, welcome to chapter 5 and part 1. We'll try something different today. I'll just do a review of some of the important points in this chapter. One of the first things that comes up is what is common to all lipids, what are the common properties they all share, and that would be the fact that they do not dissolve in water, even though they have different chemical compounds, different breakdowns. If that's not something necessarily they have in common, but they do have this in common. They do not dissolve in water, as you well know when you try to mix salad dressing, that you have to have some kind of emulsifier, which we'll talk about, to keep the oil suspended in the water medium. So if you look at this slide, that just points up some of the major items in this chapter. We'll just look at some of them in detail. So the review is there's 3 structural forms of lipids. And so if we want to know what those 3 forms are, then we need to look back and see that there are triglycerides, phospholipids, and sterols. So triglycerides are the most common way that fat is distributed in our body. They are insoluble, just like we said, and could be liquid or solid. So we'll talk about saturated and unsaturated. It's how we store in our bodies, how we store fats. And they are metabolically active, that we can use them. Your cells can break down the fats and be useful for energy sources. Phospholipids are a more complex, they're called a complex fat. They are soluble because they're attached to a phosphate. So it's a lipid with a phosphate attached to it, which is soluble in water. So that makes the fat soluble. And we saw this already in the cell membrane, that there's a fatty acid and there's a phospholipid. So these are active in the cell membrane, and they also is a way we transport fat, because obviously if the blood is a water medium, they have to have something it can transport. So by attaching fats to a phosphate, they are soluble. The last type is a sterol. This structure is a little different. We'll see in a minute. This is a ring structure instead of a phospholipid, and it's produced in our body. So we can get it from food, animal products, or our body makes it. So they haven't limited so much anymore how much we ingest, because we will make enough for our bodies if we don't ingest enough. It's also the basis for hormones and vitamin D and bile. Bile is largely cholesterol. So those are the 3 places you will see it in use. So the next thing to review is fatty acid versus triglyceride. So what's a fatty acid? Well, what's a triglyceride? So for this, if you remember that, if we look at this slide, the most common form of fats and oils is triglyceride. What is it? Tri is 3, glycerol is the glyceride or glycerol. So it's 3, it's like a flag. You've got the glycerol backbone and the 3 fatty acids. Or if you see it in a structural, each of these would be a carbon molecule attached. So it's a long carbon chain. It's a hydrocarbon, hydrogen carbon attached in a long chain and then attached to the glycerol. So that is a triglyceride, or a monoglycerol would be just taking off 2 of those, or a diglycerol would be taking off 1 of those. So as your body breaks down triglycerides, they become diglycerides and monoglycerides, depending how far along they are. So here is a diglyceride with just 2 fatty acid chains on the glycerol background, or one fatty acid chain on the glycerol background, a mono. So once the lipase, which is the enzyme that is in our saliva and also in our small intestine, can break these bonds here, so the fatty acids are free fatty acids. You've probably heard that mentioned before. So the next distinction in this chapter would be looking at saturated versus unsaturated. So for every fatty acid, some have double bonds and some have single bonds. That determines how the fatty acid will behave. So we know that saturated fatty acids are solid at room temperature. Unsaturated could be liquid or semi-solid, depending on how saturated they are. So for that one, if you look at this slide, you can see that a saturated fatty acid has all single bonds. So if this were a long chain of carbon chain and hydrogen, each of these would have only one bond, whereas this is the unsaturated fatty acid with a double bond, which creates a different substance. It's somewhat more flexible, this double bond, so that's why we have a liquid product. So if you have more than one double bond, it would be called unsaturated. But if you have just one double bond, it's mono unsaturated. So you can have mono or poly unsaturated fatty acids. Poly meaning many, and mono being just one. So if you've probably heard of the monoglycerides, are the ones that is like olive oil as an example of a monoglyceride, and mono unsaturated fatty acid, or a polyunsaturated fatty acid would be like corn oil or soybean oil, a lot of the oils that we're familiar with. So that's the difference between those. And then if you look at the next topic that we might want to review, it asks us what is cis and trans. So there's a different formation. Once you have an unsaturated fatty acid, it could be in two different forms. And the only reason this is important is because you might have heard in the literature that trans fat is dangerous. So actually it has been, FDA has outlawed the use of trans fats, fatty acids, because we do not have the enzyme. So it's a synthetically transformed fatty acid. So instead of just making a normal straight fatty acid, the trans changes the configuration of the double bonds, whereas the cis, the two sides of the chain are on the same side. The trans, the two sides are on opposite, the two ends are on opposite sides. So here's oleic acid in its trans form. So they can take what's a normal oleic acid, it's a fatty acid, and change the shape. So these trans fatty acids are not natural. Our body's not familiar. We don't have the right way to break them down, so they're causing higher incidences of heart disease. So that is done. The reason that we even consider that possibility is that back in the early days, there was a problem with oils. There's still a problem with oils becoming rancid, but they discovered by changing the configuration of the shape of the fatty acid, it wouldn't go rancid. You could keep it on the shelf longer, and you could sell fats for a longer period of time. So it was important. In the 40s, they discovered that would be a good way to store fats and put them in a grocery store and not worry about them going rancid. Polyunsaturated and monounsaturated, then we just talked about. That is the difference between whether having many unsaturated, many double bonds, or just one double bond. And cholesterol is different in that it has a ring configuration. So instead of being a straight line, these are quite different. This is a sterol in a vitamin D. So we know that vitamin D has sterol in it. So these are the shapes of cholesterol. It's a ring formation. So it is a different. And then the last question on this review question was the essential fatty acids. So what are the essential fatty acids? What it means is that we cannot make, just like we can make cholesterol, we cannot make the essential fatty acids. It means we have to get them from our diet. So I'm sure you've heard omega-3, omega-6. So these are essential fatty acids, and they are unsaturated fatty acids. So the two that we hear about is omega-3 and omega-6. And that just means where the location of where the double bond is. That's why they're called omega. So from the omega end of the fatty acid, the first double bond is the third carbon from the omega end. So that's why it's called omega-3. Another name is alpha-linolenic acid. So that's one of the essential fatty acids. And then if you had omega-6, that just means that the first double bond is the sixth omega-6. That's the omega-6, the Greek letter. So 1, 2, 3, 4, 5, 6. That's the first double bond, omega-6. So that's the name of the other essential fatty acid. There's also omega-9. It's another fatty acid that it's a monounsaturated fatty acid that we can produce. It's not essential. So that just explains then that if you ever want to take like a fatty acid supplement, you might see DHA or EPA like fatty fish. You can actually get these. These are breakdowns from omega-3, so you can bypass. You could take these. Are also important for your body, for your brain and nerve function. So you can take supplements or get fish oils that have DHA, EPA. And then the breakdown of omega-6 is arachidonic acid, and there's some discussion about whether that is dangerous and actually causes inflammation. How much of that should we get? So the important thing is that at this point they're suggesting we try to get more omega-6s and less more omega-3s and less omega-6. So most of us are getting up to 15 tablespoons a day of omega-6, but only 1 tablespoon of omega-3. So our imbalance of a type of fat has been possibly causing some inflammation, insulin resistance, leptin resistance, and obesity. Those are some of the theories that have been shown in the literature. So that is the review of this section where we talked about the essential fatty acids, their function for brain and nerve function, their configuration and why they're called that. Oh, we didn't talk about food sources, but the food sources of these fatty acids are olive oil, we've heard of, is a good source. Another one would be, let's see where that slide, here we go. So here, omega-3 flaxseed oil, salmon, cod liver oil, butter, and then some of the fishes. And then for omega-6, these are the things we see more often: sunflower, corn, soybean oils, canola oil. Those are much higher in omega-6. So this is the focus here, is to try to more fish. That's why they suggest 2 to 3 fish a week. 3 times a fish probably is the best recommendation. Okay, so that's the end of that review. And then one other review then is we're just looking at, we did all of those, is looking at this one. So the last section in here is where do we get these oils? So what food sources have saturated fat, monounsaturated, polyunsaturated fat, and where do we get cholesterol? What is an emulsifier? So just in the last couple minutes, if you look at the emulsifier, we can look back here, we can find out that because water and oil do not mix, we can include something called the phospholipid is actually a type of emulsifier because it has a hydrophilic and hydrophobic end, and so it can take fat and suspend it in water. So examples of emulsifiers are bile acid. That's why bile is a good product to have in our digestive system. Lecithin, you can get lecithin naturally in wheat germ and peanuts, organ meat, soybeans, and then some food products will have lecithin added. So emulsifying is allowing the oil and water to be suspended. So it breaks the oil into very, very small particles, and then it can be suspended in water. When we're doing later, we'll talk about digestion of fat, and you'll see that in our system of digestion, it'll actually form what's called a micelle. It's a way of carrying lots of little fatty acids through, or in a globular fat. This phospholipid layer carries the globular fat through your digestive system. So that's another way the emulsifier will work in our digestive system. And then why we were worried about rancidity. So we know that fats, because they can be oxidized, they can taste bad. If you've ever smelled food that's been sitting around, like a biscuit or something that's been around for months, it has an off flavor and smell, very unpleasant smell. And so that's why initially they went ahead and did hydrogenation to try to protect rancidity from occurring. So that was the initial reason. And then early on, they would actually take and make oleo butter and sell it, oleomargarine instead of butter. And they had special coloring you could add to it because the dairy industry was not happy with them selling oleomargarine to begin with. And the last thing is a hydrogenation. So that was the system that goes through to take and make what is normally a double bond and make it a single bond. So they, under high pressure, you could take oils and they can become much more saturated and so they're semi-solid. So whenever you see a partially hydrogenated item in your food, it means you have more saturated fat than you might have had otherwise. So that's not necessarily healthy, and those are the trans fat that we talk about that has been formed. So we're limiting our use of hydrogenated fats, which means limiting deep fried foods, high fat baked goods, and non-dairy creamers because of the trans fat. So that is the first part, some review of the first part of chapter 5. The second part will be more about the digestion. Okay, thank you.